We're
awesome.
All right. So I'm here with Jack Andraka. Jack, a real pleasure, pal.
Thanks so much.
Great to
be
have
here.
you here.
Thanks, yeah.
So I want to capture your story on the extraordinary adventure you've been on as really inspiration for everything from other high school students to adults to entrepreneurs to make their dreams come true.
Yeah, definitely.
So first of all, how old are you today?
So I'm actually 16 years old right now.
16.
I'm a sophomore in high school.
And where are you in high school?
I am sophomore year, and so I still have 2 more years to go.
Okay. And if someone were to ask you, why were you on the TED stage and why have you been on TV channels around the planet, what are you being recognized for right now?
So currently what I'm being recognized for is I created this thing like a diabetic test strip. And essentially it can detect pancreatic, ovarian, and lung cancer for 3 cents, and it takes 5 minutes to run. And so this makes it 168 times faster, over 26,000 times less expensive, and over 400 times more sensitive than our current standard of pancreatic cancer detection. But also it has close to 100% accuracy, and it can detect the cancer in the earliest stage when someone has close to 100% chance of survival.
All right, so that's a mouthful, and it's phenomenal. So let's back this up a second. So you basically created a extraordinarily revolutionary, simple, fast, cheap, accurate test for pancreatic cancer, ovarian cancer, and a multitude potentially of other cancers. And you're not even sure how wide it can be used. It may have a lot of applications. Right?
Yeah, so essentially what's so cool about this sensor is how versatile it is, how it can be rapidly extended to potentially any disease in the world, because you switch out one component of it, and then, for example, you could detect malaria, you could detect AIDS, Alzheimer's, other forms of cancer, and it's very fast, it's very rugged, so for example, you can use it even in the harshest of conditions. It's very hard to denature it. And so
let's actually, let me pull you back here, and let's start, because I know you're just, the amount of passion and energy you have is infectious. I want to tell your story in a logical fashion. What started you on this journey? And how old were you and what was going on? So take us back here a little bit.
So when I was 13, I actually became interested in pancreatic cancer diagnostics because a close family friend who was like an uncle to me passed from the disease. And then when the disease hit so close to home, I knew I needed to learn more. So I went online and I was just looking through pancreatic cancer statistics, and what I found really shocked me.
What did you find?
Over 85% of all pancreatic cancers are diagnosed late, when someone has less than a 2% chance of survival. Also, the current test, which is 60 years old, it costs $800 per test, and it's grossly inaccurate, missing 30% of all cancers. And your doctor has to be really ridiculously suspicious in order to order this test for you, because it's really not working whatsoever and it misses all these cancers, and that's why we have 85% of them being diagnosed late. So I knew there had to be a better way.
And so that is amazing. What was the aha moment for you that how did you come about creating this diagnostic test?
So my aha moment, essentially my eureka moment, actually came in my high school biology class.
And so how old were you then?
I was like 13, 14 then. And so just in 8th grade, and I snuck in this article on these things called carbon nanotubes, essentially.
And why did you sneak in this article?
Well, because my biology class, it's the typical high school biology class, and I had already known the majority of the information that we were learning in there. And so I became really interested in these carbon nanotubes, and then I was just like, well, who cares about biology class? Let's just sneak in an article on carbon nanotubes. That's much more interesting. Because they're kind of like the superheroes of material science. They essentially have all these amazing properties, and also they're really inexpensive, about $50 per kilogram right now. So I was thinking, oh, let's read about these amazing super materials. And then essentially we were learning about things called antibodies, essentially molecules that only react with one specific protein. And so in this case, that molecule that would be reacting to would be this cancer biomarker called mesothelin.
So backing up a second, so you're in your 8th grade biology class, you're actually, during a lecture, you're reading an article about carbon nanotubes.
Yes, I'd snuck it under my desk and I was just like...
And so you're just sort of reading along and learning about them, how cheap they are, how versatile they are, how cool they are as a material.
Yeah.
And at the same time, your 8th grade biology teacher is talking about antibodies.
Yes.
And an antibody is what?
An antibody is essentially a molecule that only reacts with one specific protein. And so I was thinking of applying that maybe to detect pancreatic cancer, as these cancers, they put out certain proteins into your bloodstream when you have them.
And so, I mean, literally during this class, you started saying chocolate and peanut butter, carbon nanotubes and antibodies, if I put them together.
Yeah, so essentially it was just this wild, crazy idea I was thinking of. And I essentially thought that maybe I could take the carbon nanotubes and have a network of them, and then put the antibody and kind of weave it in there, such that you have a network that only reacts with one specific protein. But also due to these amazing properties of the nanotubes, the network would only react with one specific protein, in this case the cancer biomarker. In other words, I was pretty sure right then that I had created a new way to detect pancreatic cancer.
So what role would the carbon I know what the antibodies would react to a protein from this particular cancer. Mm-hmm. What role would the nanotubes play in this solution?
So the nanotubes, their purpose is essentially to kind of quantify how many of those antibodies are reacting with the antigen. And essentially what happens is when you have this network with the antibodies in it, then you have the protein and it's introduced to this network. It actually goes into the network and forms this larger molecule with the antibody. And this rips the nanotube network apart, and it separates neighboring nanotubes, and this causes a change in the electrical properties, or the resistance. And then I could just measure that with a $50 ohm meter that I stole from my dad.
And so you had this aha moment, and you had basically a theory at this point.
Yeah.
And what did you do next?
So next what I did is I was actually worried that this was just some wild idea that a kid was having. And so I told it to my parents at dinner, and they were just like, Jack, what are you doing? This isn't a possible science fair project. Let's instead focus on something more simple. And I was just like...
Were you looking for a science fair project?
Yes, I was actually looking around for a science fair project. I was like, this could be my science fair project, because I want all of my science fair projects to have a meaningful impact. So for example, earlier ones were like detection of different water pollutants. And so this one I was looking at possibly revolutionizing cancer diagnostics. And so then essentially I was just doing a bunch more research to kind of validate my theory. And then once I kind of felt a bit comfortable, I wrote up a budget, a materials list, and a timeline, and I sent it out to 200 professors at Johns Hopkins and the National Institutes of Health. And essentially I was emailing anyone that had anything to do with pancreatic cancer, because I just wanted a lab space to do my work.
And how much money were you looking for, and how much time did you think it would take?
So I said, this should only take 3 months and maybe $1,000.
You were looking for just $1,000?
Yeah, I was just looking for $1,000. Little did I know how much antibodies cost at the time. Okay. But essentially I go into this, afterwards, after I sent out all those emails, I got 199 rejection letters. And they were just like pouring in. Like every day I would get maybe like 10 rejections. I was just like really disheartened at that moment. But I was just like, I should probably keep going through this. And at the end, I finally got one maybe from this professor, Dr. Anirban Maitra at Johns Hopkins. And so I go into his lab for an interview 3 months later, and I sit down, I start talking, and he starts throwing these wild questions at me that I hadn't thought of at all. So I was guessing on a lot of them. And then he starts calling in more and more PhDs who specialize in nanomedicine and carbon nanotubes, and they're firing all these questions at me. And an hour later, I kind of like stumble out, like my brain's hurting at that moment. But I got in the lab space, so I was really, really happy. And then as soon as I started working, I realized that my brilliant procedure had like 1 million holes in it. Everything was going wrong. Like my antibodies weren't reacting, nothing was working. And so I did go over budget, and I went about 2 times over my projected timeline. I went through 7 months. And however, I ended up with this one small paper sensor that costs 3 cents and takes 5 minutes to run and could diagnose pancreatic cancer and potentially any disease in the future.
That's extraordinary. So just to hit those numbers again, because I think the numbers are important here. This paper sensor, which has the antibodies and the carbon nanotubes attached, mm-hmm. Costs 3 cents per test to run. Mm-hmm. And what were the statistics you gave again in the beginning? Give them slowly.
So this makes the test 168 times faster.
168 times faster than the traditional test.
Yes,
Meaning
which takes like
time,
8 hours or 14 hours.
And this one takes how long to do?
5 minutes.
5 minutes as compared to 8 hours.
Yeah.
So 168 times faster. Second thing?
26,000 times less expensive.
So 26,000 times less expensive. So it's 3 cents versus
$800.
$800. Okay.
And then it's over 400 times more sensitive than the current standard, meaning that it can detect extremely small amounts, femtogram amounts of a protein in your bloodstream.
And the protein that you're measuring, you said was
mesothelin.
Mesothelin.
And it's just found in your bloodstream when you have pancreatic, ovarian, and lung cancer, but also in the earliest stage when a patient has close to 100% chance of survival. So you're lifting the traditional pancreatic cancer survival rate from 5.5% to close to 100% with this test.
Phenomenal. So 7 months after you started at this professor's lab, what was his name?
Dr. Anirban
Maicha. You had a working sensor.
Yes.
You missed your $1,000 budget.
Yeah.
How much do you think you guys invested?
I think we invested about $5,000 in the end.
$5,000.
Yes.
Okay. And do you have any idea how much is spent on pancreatic cancer every year? Probably hundreds of millions of dollars.
Yeah, and then all around the world, it's probably a couple billion.
A couple $1 billion. So a $5,000 investment to revolutionize it's a reasonably good return.
Yeah.
And then, what did tell me about that moment when the first sensor worked. What was going on? Who was there? What did you think? Talk about that.
When the first sensor actually started working, it was really late at night. It was like around midnight to 2:30 in that range, and no one was in the lab. Like
just
everyone clears out around like 6 o'clock. I just kept working, and it's just like.
Is that normal for you to keep working late?
Yeah, I usually went like until about 10, but this time I was going until 2:30. So I was in the lab and I just put on the blood sample and I was testing it. And then all of a sudden I got this amazing response. Like it just started climbing up like the resistance. And so I was like, this is actually working. And after that, I ran around screaming around the lab. Luckily no one was there to like be like, wow, that kid's really weird. But essentially after that, after my initial bout of excitement, I finally got down to the science, and then I finally got it like all through all of the trials, 100 patient samples later and tons of repetitions at my dismay because my professor was like, you have to repeat these like 10 times. No one's going to believe you. So after that, I finally had that sensor and I was so happy.
Oh, that's extraordinary. So your story reminds me of the challenge I had going to 150 people to fund the Xprize and everybody saying no. So I want to back up a few parts. Number one, why did you keep going?
So I kept going because my main motivation was that I knew 100 people die of pancreatic cancer every single day. And every day my mission is to say, how am I going to help save those 100 lives? And then also I always think, how am I going to make sure that everyone will have that one uncle or that one relative just a bit longer?
So if I'm going to list the things that drove your success, I'm going to extract this list. Number one, you had a massive, passionate drive. You were driven by your passion. You were driven by a huge mission. Mm-hmm. So that was very important. What else do you think led to your success?
So probably what else led to my success is kind of like the inner scientist within me. I'm just like, there has to be a better solution to this. Because in mathematics, for example, I do a bunch of math competition. And in a mathematical proof, you're always looking for the most elegant, short, simple solution to this vastly complex problem. Sometimes they're not too simple, like a 170-page proof to like a one-line problem. But I was thinking there has to be like this one-line solution to this problem. And that kind of just fell out in biology class. So
if I could extract then the second piece of advice, the second thing that's led to your success is just the belief, your gut sense, your inner belief that there was a more elegant solution. There had to be a better way.
Yeah.
And just persisting until you found that.
Yeah, because when you tell a teenager no, they're going to be like, I'm going to do this no matter what. Well, that's at least me. I'm very stubborn at times. So I was just like, I'm going to get this done.
And would you say did you have a belief that it didn't matter how big risk you took? You weren't scared of failure at all, were you?
I wasn't very scared of failure because who's going to care if a high school student fails at curing cancer? No one's going to be like, oh, look at him, he just failed. Someone's going to look at you, for example, if like there's massive billions of dollars on your hands. But in my case, I was able to fail because I had this one like cubic meter of lab space and I had $1,000 and that's it.
So you were risking a small amount of time, a small amount of money, and you were willing to take big swings at the bat.
Yeah.
And you didn't care if you failed. So that's I would say a third part of your success. Was your willingness to take to go after this and not fear failure.
Yeah, and that's even true, for example, nowadays. I just was working on like the Xprize even now, on the Tricorder Xprize, and I'm like, so what if I fail? It's cool that we tried. So that's my philosophy.
Another thing, if I might, that might lead to your success, I posit that sometimes an expert is someone who can tell you how it can't be done. And so, because perhaps you weren't an expert in this field, you were willing to try very novel ideas. Is that something that you believe is true?
Yeah, that's definitely true in my case, because I had no clue about anything about carbon nanotubes or antibodies. I just knew enough to get the solution to start working. And that's been true across the ages. For example, the cowpox vaccine. We didn't understand vaccines until like a century later, but that was the solution that worked and it eradicated this deathly disease. And so not knowing that much and not being an expert really gets rid of these preconceived blinders that you can't see these really elegant solutions. You're going through incrementalism at the time.
And so you're willing to go and take some bold shots at revolutionary new ideas, or orthogonal thinking, if you would, compared to the incrementalism that other folks. Did people tell you along the way that it was a stupid idea, that it wouldn't work?
Oh yeah, like all the professors, like one of those 199 rejections, the guy literally went through every single sentence of my procedure and said why it was like the worst possible mistake and why I was completely mistaken in doing it. And then also he would say how the entire idea was a failure and carbon nanotubes couldn't do anything. So I was just like, oh, a lot of them are really mean, but some of them are a bit nicer.
Wow. I wonder, have any of them written back to you to tell you they're sorry?
Well, actually, what's so cool is right before I won the International Science and Engineering Fair, there's a thing at Johns Hopkins University, and it was an expo of all the different research from across the year. And so my professor let me enter in it, and all the other professors were there. And they all got to see my work, and I beat all of them. I got 4th place in the expo.
So this has been... So how old were you, and when did you announce the results of your work?
So when I announced the results of my work, it was probably at my school science fair. It wasn't the big press conference, but essentially I was 15 at the time, or 14 at the time. It was in December. And then the big public announcement was pretty much at the Intel International Science and Engineering Fair when I won the grand award. And then everyone was all over it.
And let's talk about the Intel Science Award, because that was a huge accomplishment. How many kids entered that?
So actual participants in the fair, there are 1,500 from over 70 different countries. However, those 1,500 participants are actually pretty much the top people in each of their countries. And so it's the top cream of crop going into one room. And I was in the medical category, which is notoriously uber competitive. And I'm just walking up and down the lines, and I'm like, there's no way I'm going to win this. I mean, look at that project. They cured Alzheimer's. Look at that project. And so I was freaking out, but then judging happened, and it was a complete day, 16 hours straight of judging. And I walked dazed out of that. And I felt pretty confident, though, because I got a lot of judges, and they all really liked the project. And I think going to ISEF was probably one of the most rewarding experiences of my life, because it had been my childhood dream since the age of 5. That's one of the reasons that I got into science fair, because I saw the winners on this one magazine, and I'm just like, I want to go to ISEF. I didn't think I was going to win it. I was just like, I just want to go. I don't want to win. I just want to go. But also, a bunch of the people that I met there are now on my Xprize team, and so we're all working as the high school Generation Z team.
That's amazing. So, first of all, the cash award was how much for the Intel Science Fair?
Well, it's a scholarship, so it's $75,000, and then I picked up $25,000 more dollars in extraneous, like smaller categories.
So roughly $100,000 of award that you can use towards your education.
Yeah.
If you decide to go to college.
Yes, I might not go to college. I'm applying for the Teal Fellowship next year, and hopefully I'll get in.
That's awesome. So let's talk about. First of all, you gave an extraordinarily amazing TED Talk. On the TED stage, you got a raucous standing ovation from the entire audience. I was so proud of you. And at the end of your presentation, you mentioned to the audience what you're doing next. And what are you doing next?
So currently what I'm working on is something called a Raman Spectrometer. And essentially it's about the size of a sugar cube. Okay, let me start that answer over again.
Sure, go ahead.
So currently I'm working on something the size of a sugar cube that'll actually look through your skin into your bloodstream and look at every single protein in there, and from there diagnose different diseases, potentially any disease, but also as applications, for example, for looking at environmental contaminants as well as explosives and sequencing DNA in a millisecond. So it has all these broad spanning applications, and it costs $5. And this is a vast improvement over the current machinery that I'm miniaturizing there, because it's called a Raman Spectrometer. And
how do you spell that?
It's like the noodles, R-A-M-A-N, and then spectrometer.
Was it the person who came up with the idea?
Yeah, the Raman spectroscopy was found about a century ago in India. This guy just observed this certain type of scattering, and what essentially happens is you fire a really powerful beam of light, a laser, at something, and 1 out of every 10 to the million photons will actually scatter in this one way, or inelastically. And from there you can detect the exact chemical composition. But the problem is current Raman spectrometers cost about $100,000 and are the size of a small car. And so I tried to shrink mine down, and it ended up being 20,000 times less expensive, over 119,000 times smaller, over 336,000 times lighter, and over 100 million times more sensitive than current Raman spectrometers.
Those are great numbers. And so you're going to use that to enter into the Qualcomm Tricorder Xprize.
Yes, I'm really excited about entering this into the Qualcomm Tricorder Xprize, because I've gathered a team of all high schoolers, and we're going to kind of incorporate this into a smartphone platform. And so we also have something they just pass over, like your heart, and it can tell you like your blood pressure, your respiration rate, like all of your vital signs in like a second. So we're getting pretty excited.
That's amazing. Do you believe that there is any problem on the planet that we can't solve?
I don't believe that there's any problem on the planet that we can't solve, because human ingenuity is not something to be underestimated, because a lot of these problems, there's always science behind them. And if you know the scientific principles, you can essentially beat any problem possible. You just have to be really clever at applying them.
Awesome. I guess, what would you say to people? Are you optimistic about the future?
I am very optimistic about the future, because, in my opinion, a lot of these technologies that we're coming out with today, they're essentially going to be platforms that we can create this exponential growth off of by Moore's law. So, for example, in the future, we'll have these tricorders that are going to be soon ingrained into us, and will just send us notifications, then also send in nanorobots and treat the disease right as it's diagnosed. And then also the singularity, and there's all these amazing things happening, and human ingenuity is definitely not something to be underestimated. And it seems the news is covering all these negative ideas, but they're not as bad as it seems, and we're going to solve all of them.
Awesome. Jack, an honor and a pleasure, and excited to have you in the SU family, in the Xprize family, and to call you a friend.
Thanks. It's great to be here.
A pleasure.
Thanks.
Thanks.
Okay, so disconnecting
That
this.
was perfect.
Yeah, it was exciting.